Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this DevOps.com workshop, brought to you by Techstrong, AWS, and CircleCI. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting workshop for you this afternoon. First, I do have a couple of housekeeping notes to cover. So today's workshop is being recorded. So if you miss any of this session, or you'd like to rewatch or maybe share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we highly encourage you to send those in to us using the Q&A tab, which you'll find on the right side of your screen. For any other comments or concerns, please use the chat tab. We do want you to get to know your fellow audience members and let us know your thoughts. We have a poll that we'll launch here at the beginning of the webinar to kind of help level set. So we really want you to respond to us there. And all of the links that are going to be mentioned throughout today's program are available in the handout section. So please check those out. Finally, before we close, as always, we're giving away 4 $25 Amazon gift cards, so be sure to stick around. So welcome everyone to this AWS Modernization Workshop with CircleCI. And I'm joined by Angel Rivera, Principal Developer Advocate at CircleCI. Angel, thank you so much for joining me today. I'm going to let you run with it from here.
Thanks, Cody. Happy to be here. Super excited to be here, actually. And help folks use and learn some new techniques within the tech space. So, again, welcome everyone. Thank you for showing up and spending some time with me. Today, I want to basically invite you to have some fun with me today. Before we get into it, let me just introduce myself real quick. My name is Angel Rivera. I'm the Principal Developer Advocate at CircleCI. And my job at CircleCI is to basically engage with the community, with all you cool folks out there that are in tech, and help you understand technology, right? Also, you help me understand technology, help me understand what you're all up to, what you're doing with technology, all the cool things that you're doing, and also some of the struggles that you're facing while using technologies and maybe some modern concepts. Let's start by talking about this project. Actually, I wanted to also mention, I did put a little note in the chat where you can reach out to me on Twitter. I'm also on LinkedIn, same handle at @punkdata on LinkedIn. So if you want to reach out to me via Twitter or LinkedIn, post event, then just reach out. I'm more than happy to engage and help with this. But before we next, we'll just talk about, I guess, a quick poll that I wanted to ask folks. I'm not sure how many folks are in the session right now, but if you wouldn't mind just identifying like what role that you currently perform within your organization. Are you a software developer? Are you more on the operations, SRE, or system administration side? Are you other, which means, it could be anything under the sun. It doesn't matter to me. I just kind of want to know who I'm kind of speaking to and engaging with, and at least the roles, right? It just helps me kind of flow with this workshop and make sure that providing the maximum value for folks, right? So please take a few minutes. We'll just wait a little bit, take the poll while we're doing it. And while we're doing that, I'll talk about the workshop itself. This workshop is generally, I try to give it within the 90 minutes allocated. So I'll be going super fast because there's a lot to cover. But just realize that, this workshop, you can find it in the handout section there. It's the AWS workshop handout. Go ahead and go to that website because we're going to be using this basically the whole way. This workshop was built in partnership with AWS. So CircleCI and AWS came together, and we decided to build out a kind of a continuous delivery workshop. This is designed to help educate folks on, the basic DevOps kind of concepts, right? And more specifically, continuous delivery and how that impacts how you build software. So if you're not familiar with any of these things, this guide, I tried to build it so that it's pretty, self-explanatory and helpful. And yeah, so one of the cool things about this is, since I'm going to be going super fast through this thing, because we only have 90 minutes, I'll definitely want you to ask questions if anyone gets stuck, and we'll try to answer them as we go through the material. But the good thing is this is static. It's going to live on after this event. So you'll be able to, continue on after, in case some people might get stuck. Maybe there's a configuration thing on your local machine. There's just tons of things that go wrong with these workshops. So I just want you to know that you're not, going to be left behind, because you can always pick this up after. So let's jump in right into it. Well, there you go. Some poll results. Cool. This is typically, if you see the results, this is typically what we see, or what I see when I give these workshops. Usually the software development roles are a little bit less than the operations or system administrator roles. And then this is actually one of the first times I've seen other kind of dominate. So that might mean that there's a few people here, which is fine. But thank you all for sharing your roles with me. This will help me kind of move this along quicker and more efficiently. So the first thing we need to do, again, this site has here, we have here CircleCI .awsworkshop.io, which is in the handouts. You can click there. It'll take you right to the sites. The first thing we want to do, though, is jump over here and you can follow along, right? So this will be a follow along with me. We're going to do is check on the workshop prerequisites. I've also included all of the prerequisites inside of the I believe I included every one of these links inside of the handouts. So if you're not familiar with these services and platforms, most of them are stuff that developers, anybody in tech who's building software is going to be using. Obviously, GitHub, right? I'm sure everyone's familiar with that. We're going to be using DockerHub, which is basically a Docker, an online central Docker repository. So what we're going to be doing is building some Docker images within our pipeline, and we're going to upload them to DockerHub so that we can then deploy them to AWS. ECS, Elastic Container Service. Then we're going to jump into doing some vulnerability scans using a really cool tool called Snyk. Obviously, we're going to be using CircleCI to kind of orchestrate all of these things together. So you're going to need an CircleCI account. And then we're going to need a Terraform Cloud account, along with an AWS account. Now, if you don't have any of these things right now, I'm going to give you about, I know it's going to be quick, but like around 5 minutes to go ahead and create these things. Hopefully everybody has all these things and they're functioning on their local dev environments, or the workstation you're going to be using to conduct this workshop. If you do not, or if you have issues, like one of the things I would recommend is, we're going to be doing some Git pushes upstream and forks. I would recommend that you create your GitHub account locally on your machine with using an SSH key instead of username and password. That way, you kind of just don't need to have any of that working against you, right, when you're doing push commands. So real quick question, is everyone here, do you have these accounts? I'll give about 5 minutes. So let's see, it's 15:09. So let's give about 5 minutes for people to jump in and do those signups if you have them, or if you don't have them. Yeah. And then I see. I'll just go through the hellos. Hi, Pat. I guess there's a participant from Las Vegas and Hungary. That's pretty cool. Awesome. So while everyone's signing up for these accounts, the next thing we're going to do is just basically jump over, actually skip this section here, this self-guided setup. We really don't need to go through this. This will save us a lot of time as well. Generally, when we do this with an AWS partner, we have folks, kind of sign up with AWS, and they have a special events engine platform. We're not going to be using that today, and they generally like to have people leverage the Cloud9 IDE workspace. So skip this. I'm just showing you this so that you understand to skip it. There's nothing really here that we're going to use today, but afterwards you can run through this real quick if you want to check out what's going on here. Unfortunately, you will be leveraging your credentials from your own accounts. Hopefully everybody has that, because we don't have our AWS partner today, and I don't have any kind of credits and stuff to share with all of you, unfortunately. But most of the stuff we're using here, actually, I think all the stuff we're using here is kind of free, should be no charge, or it's captured under the free tier, and in most of these services. I think we're good to go. Okay, so we kind of got the prerequisites. If you need that, it's in the handouts. Let's start with, I guess, the CircleCI setup. I'm looking at my time. Give people a few more minutes to sign up. Can anyone that does not have anyone that has not signed up for these services, can you just post a quick status for me in the chat? Just let me know, like, hey, need more time or whatever. I'll wait a few seconds here to see if there's anybody that actually falls in that category. Need more time? Just send me a little post in the chat section. All right. Looks like we don't. It looks like we're good to go. All right. So I'm just going to proceed. Let's just go down the list here. So obviously, right, we're going to create a DockerHub account. If you have that already, I recommend that we follow this and essentially just build create a Docker Hub access token. We're going to be using that credential. So what I would recommend is, okay, I see one person. I'm just going to go through this setup part, which you'll have ample time to go through as well. I'm just going to describe like why we need this stuff. So CircleCI will execute what we call a continuous delivery pipeline, which is essentially an automation for the things that you do manually, right? So with CircleCI's CI/CD tool or continuous delivery platform, you're able to automate things like if you do manual testing, right? Let's say you're building some new functionality or building some new pieces of code, and you need to build and run tests on it before you commit your changes, then you definitely want to make sure that everything's running, right? And the way we typically do that as like developers, we do it locally on our machines, right? Make sure everything's nice and tight, and then we commit and then push that upstream. Once you push that upstream, our continuous delivery platform will detect those changes and then execute this thing that we call a pipeline. And that pipeline is a predefined set of instructions that you have developed, so that essentially, right, you push your changes upstream, and then you kind of you don't have to worry about it until the system runs all your tests, and you only really have to worry about it unless you fail. Now, again, the continuous delivery platform is basically a full-fledged automation tool. So that means you can execute a bunch of things on it, right? So you'll get a better sense of that as we move on in this presentation. So the first thing, again, we're going to do is create this DockerHub account, or I'm sorry, this DockerHub access token. What I would recommend you do is just open up like a text editor and then save off all of these access tokens that you're working with, right? You're gonna record them. We're gonna build them or create them, generate them, then record them in a text editor for each service, so that we're going to use them later on in the configuration for CircleCI, which is further down in the workshop. The next thing I want to talk about is creating an access token for Snyk. Snyk is basically a security platform, and it's basically designed to enable you for developers to do pretty extensive security vulnerability scans on mainly the dependencies that you're using in your code base, right? So, if you're a developer and, you're not familiar with security, Snyk is a great way to kind of get familiar with security. And it's an easy and low barrier to entry into the security realm as a developer, right? All developers that I know, and I'm sure most developers, don't want to write insecure code, right? We want to write quality code. And one of the ways we can do that is by leveraging tools like Snyk to do that. So please follow along, grab create a Snyk access token. Again, save that off into a text file because we will be using that later on in the workshop. The next thing I want to talk about is this Terraform Cloud bit. What Terraform is a tool. I don't know if anyone's ever heard of infrastructure as code. So infrastructure as code enables folks to basically build critical infrastructure within a cloud provider. For instance, we're going to be using AWS, which is a pretty well-known, popular cloud provider today. And basically all the things that we need to build, like servers and services and networking and security groups and access controls, are all going to be done and defined and executed via a code platform called Terraform, which is an open source tool created by HashiCorp. I've been using it for many, many years. It's a really cool tool, very reliable. I like it because I can, create infrastructure and then tear it all down when I don't need it anymore. So it's great for that. And we're going to show you a good example of that. But Terraform Cloud, since we're creating infrastructure, Terraform Cloud provides you a way to basically manage the state of that, right? So imagine if we create all these things and then we just leave it hanging in AWS, right? That could be very expensive, especially for infrastructure that you're kind of just using for testing or you're not really using all the time. You definitely want to tear that down for many reasons, right? Cost is probably number one, and I think a very close second or tie is security, right? You don't want these infrastructure sitting around and people being able to kind of maybe poke around and gain access. So the less stuff you have exposed or out there that's not really being used, it's probably best just to tear it all down. But with Terraform Cloud, just create that access token and follow these instructions here. This gets a little bit more involved. What you're wanting to do here is essentially create a cloud organization. We're going to call it whatever you want to call it. But remember to record that cloud organization because we're going to be changing some code later with that. We're going to create a new Terraform Cloud workspace. This stuff needs to be pretty static. So try to stick to the naming convention. Otherwise, in the future, future modules, the code will not work, and it'll be due to naming conventions and stuff like that. And just follow along. Right, click the CLI driven workflow option, and then what we want to do is create a local execution mode, which essentially will just run this in the CI platform instead of on the Terraform Cloud. And again, right, once you're done with all that, you'll just create this Terraform API token and then record that, save it off, right? So remember the organization name, you're going to have to record that, and then you're also going to have to record the API token. Again, if you have any questions, feel free to just, pop them into the Q&A. Cody will help us out, help me out at least to keep track of all of it, and then call out the questions as they come up. So don't hesitate to ask questions. And I'm willing to discuss anything, the tech, whatever you see behind me, my workstation, whatever. If you're curious about what that is, we can talk about that too. So, right. So the next thing we need to do once you have your AWS account all set up is obviously create these access keys. So what we want to do is create security credentials for a service account that we'll be able to use in our CircleCI, CI/CD pipeline and jobs. Be very careful with where you save these access keys off. Actually, when you create this, it's only going to allow you to see the access key on the point of creation. So once you see that, you can actually, I think you can download, and it downloads to like a CSV, so you have it, or you can just copy and paste those access keys into that text file where you have all the other tokens that you're creating. The instructions here are pretty simple. If you click on these things, it should help you quickly create the things that you need, and you can follow along here. One of the other things that we need you to do is create an AWS key pair. Again, the instructions are all here. Just remember to use this name. It's very important. Otherwise, your pipeline will not work in further modules. So the next thing is what we're going to do here is get the actual code repository project, right, that we're going to use. So this is what it'll look like. It's on GitHub. You can get basically all the code examples here, or fork this, right? So you're going to have to create a fork. I already have one. I would just recommend that you fork it and then follow the instructions here, clone it locally. When I mentioned the SSH keys, if you're not logging into, if you're using a username password login protocol to GitHub, I would recommend you switch over to SSH. And then, you know, if you already have that set up, then you can skip this. But once you have it set up, then I would, you know, just copy this. You can ignore this Cloud9 comment. That would just happen on your the machine that you're actually going to use today in the workshop. So I'm looking here. Yeah, pretty much simple. And then you can paste your public key into the GitHub interface so that, you know, you'll be able to get clone, push, do get transactions from the machine that you're gonna be using today for the workshop. Again, just fork over that repository, and once you have that in your namespace on GitHub or in a repo on GitHub, follow all these instructions to set up your machine. If you have this already set up, most of you, I'm assuming, will have this set up with SSH. That's great. Don't have to do much except for fork it, right? And then clone it locally. Once you have that, you know, project clone locally, you should be good to go. And then finally, now we can get into the nitty gritty about continuous delivery in CircleCI. So what's going to happen is once all of these setup CircleCI steps are completed, we'll jump in here. As a matter of fact, let me pause and let folks kind of catch up. I know I'm blowing through this super fast, but I've done this many times in 90 minutes, and I have to do it. Apologies, but in order to kind of finish on time, and you know, if we finish a little early, then we'll have more time for Q&As and stuff like that, which is much more fun for me. To help folks, you know, understand things a little bit better. So I'll just set back for, like, let's say 3 minutes and let folks kind of catch up. I know there's a lot going on here, but like I said, you know, we can always go back, and you can always go back after the event and you know, finish or fix things if need be. I'm going to go ahead and check. QA, nothing there. Perfect. Yeah. Okay. Let's go ahead and proceed, since again, we're running low on time, or we have limited time. Hopefully folks have gotten most of this stuff done. I think the biggest one is the Terraform Cloud and the AWS systems. But what we're going to do next is jump into creating the project, right, within the CircleCI platform. CircleCI is pretty simple. All you have to do is click on this link here. And I'm going to do that just to kind of show you what's going on. I'm in incognito mode, so I did that on purpose so that I could show you. You can log in multiple ways. I'm just going to leverage the GitHub login. So what that does is an OAuth ceremony. And then what you're doing here, oh, great. So you get to see me leverage a two-factor, which is easy. I get it off my phone. And what we're going to do here is basically, enable a CircleCI to connect to your GitHub repo and perform, basically observe it and then perform transactions against it, so you can execute things against that code. And obviously, if you're going to build things on CircleCI, we need to have permission to do so. Well, this is great. So obviously, right, we're a very secure organization, which is cool. But this is how we actually operate, right? So in a second, I should see, yeah, there you go. So now I've logged into CircleCI. I'm going to go with my Datapunk. As you can see, CircleCI enables you to it checks all your GitHub organizations. So GitHub has organizations within that. But right now, I'm going to be looking at the project. So if we jump back over here, follow the instructions, right? You're going to find your AWS CircleCI Modernization workshop code. I already am following that, which is this one here. So essentially, I don't need to do the steps that you're going to accomplish here. But if you follow along with the project, right, just select the fastest option, which is here. And then in this text field, type the branch name called name. Type the branch name called main. That'll get you, should get you the blue button to enable, and then you can click the setup project. And once you have that, you should see something that looks like this. And yeah, as you can see, what you're looking at is the CircleCI dashboard, and this dashboard essentially shows me all of the things or all of the builds that I have run against my code base. Again, obviously, right, I've already done this. You should see something that looks like this as the initial build for your project. This is just a default configuration, right? Because we don't want you to fail the first time. Failing, I believe in failing. It's great because it tells you what's going on with your code and the bad things that's going on, the things that you need to pay attention to with your code. But the first time around kind of sucks, right? When we fail, but that's okay too, because that gives you opportunities to fix it. So great. I'm going to jump over to this again, which is the workshop. This is really important. So all of those access keys and all those things that you saved off, right, from those different services, this is where we're going to start using them. Once you have your project all set up in CircleCI, all you really need to do is just jump over to like the hamburger here and select the project settings. Now, from project settings, what we need to do is select environment variables. And as you can see here, I have a list of environment variables, right? And if you jump over to this list, they're all listed here, the things that you need to populate in there. So like, Docker login, Docker password, just copy these names here. This particular one here, we don't need to use. Just ignore that one. The one that says AWS session token, we're not going to be using that because we're not, as I said before, we're not doing a joint hosted thing with AWS, and we're not using their events platform. So ignore that one. Other than that, copy all of these environment variables and then save the corresponding key. So let's take a look. So let's say I'm going to type in Angel. I'm just showing you how to use it. Rivera as an environment variable, and then here, it could be just some text, whatever the value is. So, if you have your access key, whatever that is, put that in and then save it off. And you can add that environment variable and then it'll be saved here, right? So as you build your list, you'll see things being built out. I'm going to delete that because we don't need it. It was just a demo kind of entry. So once you have all of these things in here, by the way, if you see things like launch darkly or whatever, don't worry about that. That's just my configuration. What you need to worry about is having all of these things in this black box here defined, and then the values that correspond to them. So give you a few minutes to build that out. At the end of the day, this is what it should look like, at least, the environment variable names. Obviously, the values for your keys will be different. One of the things I wanted to mention also is that we have a very secure platform. So entering these keys inside our platform, they will be saved, encrypted at rest, and also in flight, as well as when it lands in the runtime. And then once it's done, that runtime is killed or terminated, I should say, and then those things no longer exist, right? But again, these are just things that the runtime is going to use on your behalf to access things. So I'll give you a minute just to kind of get through this. I know there's a lot going on. Be sure to make sure that there's no spaces when you're implementing this. Sometimes I'm not sure what's going on, but if there's spaces behind these values, sometimes they can cause failures or weird errors. But yeah, if there's anything like that, please hit me up. I see it. I'm going to stop and let people do a catch up. And then I'm going to answer a question here. So the question is, what gives an edge to CircleCI compared to other CI/CD tools? Good question. So there's a lot. I used to run infrastructure before at various companies and organizations before I joined CircleCI. I was a customer, and before I was a customer of CircleCI, I leveraged a bunch of different build tools like Jenkins. Travis CI was one. But for some reason, I know why, but CircleCI just seemed like a more more modern CI/CD tool. It gave me a lot of the features that I was looking for in the old days, more so than the other tools that were out there. Fast forward to today, where you have a more integrated tooling like, let's say, GitHub Actions or even GitLab CI. The difference for me between, like, let's say those other cloud providers is those providers are trying to give you a full experience within a version control system. So the CI functionality is kind of baked in as a feature, whereas CircleCI, we're a full-on continuous delivery platform. That's all we focus on, is how do we help developers and teams build software faster at scale, right? And with more consistency, reliability, performance is huge, right? So we spend a lot of time making sure things just run really, really fast and kind of remove all the cruft of the other distractions. Like if you're running a Jenkins system, you obviously have to stand your own machinery up, right? And then run those clusters. With CircleCI's cloud platform, we have both flavors. If you need, you're in a compliant space, you need to stand up your own kind of infra to run your continuous delivery for your company. That's fine. We have an option for you, but I generally just love the SaaS portion of this, because all I have to really do is manage the pipeline configuration file, which I'm going to show you soon. So I hope I answered your question. We can talk more about that later if you like, on Twitter or LinkedIn. But yeah, there's a lot, and there's also tools and features like debugging with SSH that those other platforms don't have, which one of the things that actually caught my attention, that SSH feature has existed for forever in CircleCI, and a lot of the other tooling don't even have that, right? So as a developer, as a person who builds pipelines, that's a great tool for me to kind of debug in the environments where I'm failing. So hopefully everyone's kind of caught up now, and you're at the final stages of or have completed section 1.6. I want to now move on to the continuous integration piece. So I'm not going to go through like what continuous integration is and what it does, because I think that's going to be more of an educational process for you. So I'll defer to you in the future to kind of brush up on this if you're not aware. If you are aware of what continuous integration is, that's good. What I'm going to do next is just kind of introduce everyone into how CircleCI defines pipelines, which is really simple. The first thing we're going to cover is the config.yaml file, right? So within, I'm just going to jump over to actually, you know what? Let me try this. This is a cool feature. I don't know if everyone ever knows this, but if you are on a GitHub page and you hit the period button on your keyboard, this should take you to a because I am not signed in, right? That's why. Okay. So let's sign in real quick. There you go. Now that I'm signed in, this will take you into a web editor, right? Native on the GitHub website. So this is a nice way to kind of peruse your file system without, it's just another view. So what we're going to do here is CircleCI. This is how you basically define it. You have a folder called .circleci. There's a file called config.yaml. And this is basically the way you define your pipelines. Okay. And what's going on here is really simple. I just wanted to show you like where the file system is. And then, you can essentially just kind of read through that. So the first thing I want to talk about is the core elements of a config.yaml file. Within the config.yaml file, there are three elements, right? Let me find the next section here. And here's the skeleton, right? The main thing that you need to have, the first thing you need to have is this version key. It's all YAML, by the way. So if you're not familiar with YAML, YAML is basically a data structure. It's a declarative data structure, and it's human readable, right? So it's an easy way to kind of define infrastructure in regards to, or I'm sorry, it's a great way. The data structure is a great way to define data structures that you want to have be human readable, right? Unlike JSON or XML, things of that nature, right? Those kind of data structures, which have a lot of quotes and stuff. YAML has some rules, right? But they're pretty basic. But one of the things that happens with YAML is it has a requirement for spacing, right? So you want to indent things if you're creating lists and all that good stuff, which you can learn more about that on your own, but I'm just going to cover the CircleCI data structure within the config.yaml file. So these are the core elements, right? The versions key. Orbs is something that I'll get into it a little bit later, but essentially what it is encapsulated functionality. So think of orbs as more of like a way for you to create reusable commands and actions that you need to execute within your pipeline. And they're centrally managed in what we call our orbs registry, which you can access it by clicking that link. So let's jump down into what all these things are, right? So the core elements of CircleCI are jobs, they're executors. I'm trying to find where that section is. I thought I had one, but I don't. So the main thing that we need to understand, though, within CircleCI is that, just scrolling through here, sorry. The main thing that we need to figure out is that the core elements of CircleCI are essentially the executor. So let's talk about executors. Executors are this thing right here, right? It's a key, and the executor is where our runtime is going to, our code will execute. Like what runtime? CircleCI has 4 flavors right now. We have what we call a Docker image, or a Docker executor, which means you can run and execute your pipelines within a Docker container. Obviously, if you're going to do that, you're going to need an image key, right? And we're going to show you examples of all 2 of these things, I think, two of these things. So a Docker Executor, we have a virtual machine executor where you get access to the full machine for your pipeline builds. And then we're also going to go ahead and have options for, let's say, Mac OS type development, right? If you're doing maybe iOS development for smart devices or telephones or iPads, you have to build that on the Mac OS infrastructure or apparatus. So what we do is offer an executor, which is a runtime, a Mac OS runtime for you to do that. And then we also have Windows executors, right? So folks can basically have the run of the mill as far as like operating systems and runtimes, so that you can do all the things you need to do in automated fashion. So that covers executors, right? The next thing I want to cover is jobs, right? So jobs within the CircleCI configuration, jobs are basically a list of things that you want to execute to achieve a certain result, right? So let's talk about this. Right here, I have a job, right? So this is the jobs list. And then I have this job called run tests. And what I want to do with this job is basically test my code, right? Run an automated unit test against the code changes that I made. So obviously, right, it needs to run somewhere. Those tests need to run in an executor. Right now, we're going to use a Docker executor. We're going to use this image, which is a CircleCI convenience image called the node, because it's a node project. And then within our job, right, we have a steps key, which is another list of all the things that we're going to actually execute, right? So in order for us to test our code, we need to, number one, check out the code changes, right? So remember, when you push your code changes upstream to whatever repository, CircleCI will detect that. It will then start kicking off these jobs. The first thing you want to do, right, since we're going to do things against code changes, we want to bring down those code changes to the executor, the place where you're going to run your pipeline. So once we get down there, this is an orb declaration, right? So remember when I showed you this orbs declaration here? This is all the orbs or the packaged YAML that we're going to be using for our project. That's all that is down here. So if we look at our node key, right, this is the namespace for the orb. This is the implementation of that kind of declaration, right? So we have our node orb, and then the node orb has install packages command, right? And that's what we're leveraging here. We're going to basically run an npm install, and then this cache key here is essentially, CircleCI has this really awesome feature where you could actually, when you're building on systems, you're dependent on downloading maybe libraries and stuff like that. With CircleCI, you can cache all those like node modules in this example into a repurpose. You can repurpose that cache in subsequent CI/CD runs, right? So the first time you run this in your project, it's going to be a little longer because it's going to first download all the node modules, and then subsequent runs, right, will be a lot faster because it's just going to download the updates within the cache. Hopefully that makes sense. And then finally, we have this concept of run, right? So if we look at all the things, this is a run command. This is a command that you would explicitly define and then execute, right? So here we go. We have a key name. We'll call it run unit test, and then this pipe command, right? You have a command key. This pipe command is essential if you want to do multiple command line executions, like in this example, right? So let's take a look at it in the code. Well, actually, I don't have it here, but yeah. So we'll look at it in a minute. But basically, within the pipeline, or this is just basically a YAML kind of constraint or requirement. If you want to do multi-line. If you just have one command, then you don't need that pipe. So hopefully that's clear. And then finally, right here, what we're doing is storing the results, right? So once we test our code using this Mocha framework, we can save the results of that and pin it to our environment, right? Or our pipeline run. This is what I actually wanted to show you, which was, yeah. So let's see. If you look here, right, we have some tests that we ran. This is where you're pinning it, right? You're saving the artifacts here, which is really nice, right? So that, again, it's a tool that enables your developers to kind of figure out what's going on if you have a failure and quickly fix and recover from those failures. So what we're going to do, I kind of explained all of this. I know it's a lot to take in, but like I said, I recommend you kind of go back. And if you have any questions after the event, yeah, reach out to me, reach out to CircleCI on Twitter. We have tons of employees that are, monitoring our Twitter handle, and we'll be more than happy to help you out. And we also have other resources that I'll share later. So the first thing we want to do, let's start hacking on some code, right? Hopefully everybody has downloaded or cloned, forked and cloned the repo. I'm going to jump over to my text editor, and I'm going to open up the file. So now we're going to start building out a pipeline. And I'm going to do this in a piecemeal kind of way so that at the end of this, we're going to be able to execute this thing. All right, so let's move a little faster since we're running short on time. I'm going to delete all this, right? And then jump over here and just copy this bit of code. And then I'm going to jump back over to my text editor. I'm going to paste it, right? Now, you have pretty much all of the beginnings of a pipeline. Don't try to run this yet. We're going to first populate everything that we need to do, or all the jobs that we want to execute, and then we're going to orchestrate them using a workflow, which will come to us a little bit later. All right, so let's go ahead and just, for me, I'm just going to get this out of the way, but make sure that you paste that in. I'm going to prepare the next line because I know I've done this so many times, and I'm going to save this. So save that off. Now let's jump back over to our browser and jump into the next section, which will be the DevSecOps section, right? I'm not going to go too deep into DevSecOps, but DevSecOps is the concept of security within DevOps, right? So if you heard the term DevOps, I don't know if you know this, DevOps always had security kind of built in and addressed it within DevOps, but for some reason, the industry feels a need to kind of call it out. Maybe it wasn't implemented properly by a lot of folks. Whatever the reason is, DevSecOps now is a term, it's a thing, and it's a cool philosophy that I advise you to check out. I'm not going to jump in too far deep into it because I don't have the time. But again, if you want to talk about it or learn more about it, more than happy to help folks out. Again, we're going to be talking about Snyk because we're going to implement a Snyk vulnerability scan within our pipeline. So let's just jump right into that. Excuse me. So vulnerability scans, right? Really important. We need to make sure that our code is secure. Snyk provides a way to do that within a CI/CD pipeline because it is a vulnerability scanning tool. In this section here, right, this is just like what your current pipeline should look like. Just jump down to building the vulnerability scan section, right? Again, I'm not going to go through a lot of this. I'm just going to go over, I'm not going to repeat or cover the things that we've already covered. So the first thing we're going to do is we're going to build this scan app job, right? So we want to scan our application within our pipeline. Obviously, we're going to run this in a runtime. We're going to use the same thing, Docker, right? No news there. We've already covered steps and the checkout command. Here's a new run command. Again, right? We're just giving it a name. We're going to call it Snyk scan application files. But this is a good example of a single line command call, right? Without the pipe in YAML. And we're just going to run npm install because we have to bring down the dependencies. Now, because we already have our cache set up, it'll automatically populate the cache for us. So I'm not going to cover any of this stuff here. I just want you to understand. Oh, yeah, one other thing. I'm sorry. We have this Snyk scan, right? So again, we were using our orb, right? Our Snyk orb. We've defined it up here. Now this is an implementation of it, and it has a command called scan. These are just parameters, right, to control how you scan. I have set these to false because I know that this pipeline will fail on purpose. because if this was set to true, this will fail. Because I know this is vulnerable intentionally. I have vulnerabilities intentionally in here, but I just set it to false for the purposes of this. This monitor on build, Snyk has a really cool backend system where once you run your scans, right, and you created that API key, it knows who you are, right, or at least it knows what service account your pipeline is using, and it will update on their site the vulnerability results, right? The scan results, which is really cool. I'm not going to cover that again because I don't have the time, but yeah, if you dig deeper into Snyk, you'll see some really, really cool security type features that are really helpful. So let's go back. Let's go back to DevSecOps and then 3.2. At the end of 3.2, we're going to go ahead and copy and paste this module. So again, copy to the clipboard, and then you can jump over to your editor, and then either just add the bits that you need to. I'm just going to replace it all, and then create that. So save that off, right? And that's basically covering our Terraform. Oh, sorry, our DevSecOps section module. Great. So I'm going to jump right through here. And we're going to talk about infrastructure as code. As I mentioned earlier, infrastructure as code is a great mechanism to kind of codify your infrastructure. It's a fairly newish concept, right? And it was popularized by the cloud native or the cloud provider kind of revolution, right? Everything kind of moved from physical data centers to now being hosted in the cloud, right, on AWS. But that presents a problem when you have huge amounts of infrastructure, right? Managing something like that in a GUI like the AWS console is damn near impossible, right? I've actually run many servers within Amazon, and without infrastructure as code, I don't know how people are managing these things, either I'm sorry, I don't know how people are managing these things in a graphical user interface. It's just like really bad and super inefficient. So if you're a developer, if you're in operations, if you're just interested in tech and you're going to be dealing with deploying things or building infrastructure, definitely recommend that you check out some form of infrastructure as code technology. I like Terraform. It's been around for a long time. It's pretty stable. It's battle tested. So I like to use that, but there are other options like Pulumi is another one that I like. The difference between Terraform and Pulumi is Pulumi's actually uses, it's an SDK basically for multiple languages, and you can actually build these infrastructures using programming languages, right? So anyway, let's jump into Terraform. Now that we have pretty much described infrastructure as code very lightly, there is something that you need to do here before we can move on. This is very important. Remember, I talked about the Terraform Cloud organization. We need to insert that organization into the Terraform code. So if we go to our code base, let's go into this Terraform folder. Hopefully everybody can see that well. Within that, we have a folder called ECS, or directory. And in that, we need to change. Let me just double check, make sure I'm in the right file. I believe it is the main provider file. Where's the instructions here? Yeah, so just want to make sure. Yeah, on the back. Okay, so in this main, make sure that this organization is what your organization is, right? So if you eliminate my organization in Terraform Cloud as Datapunks, it's just an old hacking crew name that I used to use that I use for hackathons. Make sure that it's whatever your organization is, right? I don't know what you named it, but just fill it in there. So I'm going to revert this back to my original for my organization. Make sure that you change this and then save it off. After you save it off, you can just close it out. We don't need to bother with it moving forward. So let's jump back over here. The other thing that you need to be aware of as well, and I don't think you really need to do this because the code is already there, but just to verify, we do have another variables TF file that this is the key pair. Just make sure that this is the key pair. You created this previously in the Amazon console in previous steps, so you should be good to go if you use that value that we have listed here. If you don't, just change it, and then you shouldn't have to do this step. So now that I've covered kind of infrastructure as code and Terraform, these are just configurations that we had to change. We're going to touch back on some Terraform action later on in the continuous deployment module, which should be the next one. The other thing I wanted to tackle here with infrastructure as code is Docker, right? And the AWS Graviton 2 EC2 instances. So obviously, right, this is we're going to build an ECS instance in the continuous deployment piece, which we'll cover a little bit. But Docker containers, or we'll just call them Docker containers. But what we're doing with Docker containers is essentially it's a packaging mechanism, right, for your application, so that it can pretty much run anywhere, or at least anywhere where your underlying architecture, processing architecture is the same. What I mean by that is, you have ARM-based processors, and you have what we call x86 architecture processors. x86 pertains to kind of like the AMD stuff, Intel. ARM is its own architecture altogether. It's usually found in, smart devices, iPads. What's the other ones? Cell phones, right? Any kind of IoT as well. It's found in multiple things. ARM is great for those kind of applications as far as mobile devices and stuff because of the low power usage versus processing capacity, right? Companies like Apple have now adopted this ARM-based architecture within their newer devices and newer appliances. So it's gaining popularity now. And I wanted to kind of call it out to show that Amazon has also started to offer up new EC2 compute nodes, which are ARM-based, right? And they're called Graviton. So we're going to be leveraging that in our pipeline. Just wanted to call that out, make sure that folks are understanding this. And again, there's a lot going on here. So don't feel bad if you're, it's all not sinking in. I'm going super fast through all this stuff and teaching you quite a bit of things in a short amount of time. But what I just want to do is kind of cover the bits that we're going to be working with here. So if you're not familiar with Docker, again, it's just a packaging tool. We created a DockerHub account. The reason why we did that is in our pipeline, we're going to package up this sample application into a ARM capable or ARM compatible Docker image, right? And all the code to do that is already in the repository in a Docker file. But what I want to focus on is this bit here. Here's our build Docker image job, right? Again, pretty much all the same things, except for here's a good example of an executor change, right? Like before we're running our stuff in the Docker container, now we're going to run it in a full-blown virtual machine. And in order to do that was you just change that executor key to a machine. And then obviously, right, we need an operating system to run on. We're going to use Ubuntu 20.4 and then, or 20.04. And then this resource class key here, right? Since we want to build on ARM architectures, you have to apply this. You have to apply this. This property or this value, right? So we want to use an ARM. So we're going to say ARM.medium, and the medium just describes the type of capacity the runtime will have. So meaning, maybe I think the medium has like 2 CPUs and maybe 4 or 8 gig of RAM, right? If you need more horsepower or more components or more processing power or memory, then you would, we have a whole list of different capacities up to like, we even have GPU capacities, extra large, right? Whatever that looks like. But we're going to use for this example, a little smaller default runtime. So we're back to our steps, right? We're going to check out our code. Here's another implementation of our Docker orb, right? All this does is the check is going to basically authenticate your Docker Hub account using that API key, right? And those environment variables that we made earlier. We're also then going to run with our orb, we have a Docker build command. So again, right, this just makes it a lot easier and reusable and consistent. And with that Docker build, we got to give our image a name, right? And we want to keep things static. So CircleCI has, well, here's your Docker login, right? And this is the format for a Docker, an image name, right? So it's usually like the organization or whatever that's building it, and then a forward slash, and then a name, right? To keep it consistent, I'm just leveraging system environment variables that CircleCI creates in the run. And then same here with this pipeline. I'm just doing like a simple semver that ties it back into the build, which if you don't understand what I'm talking about here, I'll show you shortly when we start running this thing. And then finally, we're going to do a Docker push, which essentially, right, we're going to build this image. It takes a few minutes in the runtime in our pipeline. And then we're going to push that image up to the Docker Hub repository so that our future infrastructure that we're going to create will be able to pull that down and then deploy it. So yeah, again, there's a lot going on. There's a lot of explanations here I'm not going to go into because we just don't have the time. But what I really want you to do is either, grab this. Oh, go back one. Getting happy clicks here. Yeah, you know what? Let's just go ahead and grab the whole code again. And then jump over to our text editor. And then, you know what to do. Control V or Command V, paste it in, and then get us ready for the next module. I'm going to save that off just to make sure all my changes are there. But as you can see, right, we're building out our jobs for our pipelines. These are the things that we want our pipeline to accomplish, right? And then we'll tie that all together in the next section. So before that, I see there's some QA. Do I need to write? Let me just answer some questions our folks kind of catch up. Do I need to write a custom YAML, or can I import from other CI tools? You need to create your custom YAML for CircleCI. Every CI tool might seem similar, but they're not, right? Everybody has their own data structures. Again, YAML is just a data structure, and that's what CircleCI processes. But we have our own special sauce, right? Our own special version of YAML, or of our data structure that only our platform will consume and execute or understand even, right? So unfortunately, right now, you need to write your own custom YAML. So yeah, sorry about that, but yeah, and it's pretty much standard across the board, right? It's not going to change with any other thing. So cool. So let's jump into the next module. Basically, one of my favorites is continuous deployment. I'm not going to jump into that. You can read up on this stuff because we're running out of time, or we're getting close to running out, and I only have a few minutes left. So let's jump into Elastic Container Service, is what that is. So we talk about containers, right? All these things, which is a packaged up, a way to package up your application and run them in an easy manner and manage them, right? So Amazon has this service called Amazon Elastic Container Service, which I highly recommend if you're getting into the container space. It's a pretty cool way to kind of play with a container service at scale, right? And I like to recommend the Elastic Container Service for folks who are just starting out, especially like developers who don't have a lot of experience in this world, because versus like a Kubernetes, because Kubernetes is a very complex by design system, right? It does a lot of things, and a lot of folks kind of get when they start jumping into it as a beginner, they start kind of getting deflated once they realize, like, wow, this is a real full-blown platform that's very complex. Imagine, right? It was developed by Google employees that worked at Google at the time. Google has open sourced it, and it's designed for organizations. The Kubernetes is designed for organizations that operate in real high capacity and scale. It's getting a lot better, right? It's a relatively fairly new project. It's becoming a little bit more easier to kind of manage as a newbie or a new person to it, because they're making huge improvements on that side. But it's still, right, a really complex platform. So I like to get people's feet wet, or recommend they get their feet wet with containers and all that good stuff with ECS, right? It's a very, very powerful system, but it kind of hides all the hard parts that Kubernetes has from you, right? It's a more managed system. So yeah, definitely check ECS out, which we're going to do, right? So now that I described ECS, right? We've created some pipeline jobs that do some things for us. We're testing our code, we're doing some security scans, and we're also building an artifact with a Docker image, right? In the form of a Docker image that we're going to deploy to this ECS system that doesn't exist right now, right? So let's go ahead and dig deep into our ECS job. What I'm going to do is just copy that right there. I'm not going to get in too deep in the weeds because you can actually read up on this, but I will cover what I'm going to paste and show you here really, really quickly. So here we go. Let's go ahead and paste that in. So now I have a deploy ECS job, right? This should all be familiar. We kind of covered that already. I'm going to talk about some of the differences. Now we have a new run command, right? Because Terraform is a CLI tool, right? We actually have to install the appropriate CLI into our platform, right? Or into our pipeline, I'm sorry, into the runtime of our pipeline. Again, we're using a Terraform orb, right? Which is a CircleCI encapsulated functionality. This orb has an install. So basically what this function does is allows you to specify a Terraform version, right? So because Terraform is constantly getting updated, we're going to be using version 1.0.2. We also can tell the system like, hey, I want to use the architecture for ARM, which is ARM 64. You need to do that if you're going to build an application or a Docker image that's going to deploy to an ARM hardware or infrastructure, ARM-based infrastructure. Then the x86 normal Intel stuff is not going to. The instruction sets are not compatible with the ARM CPU, so it will not work, right? You'll be able to compile, but it will not execute on the ARM platform because the ARM processor just doesn't understand the x86 instruction set. And then obviously we're going to use Linux, right, as an operating system. There's different ones, Windows. I can't remember all the variations, but in our documentation for the orb, you can find that. Then Terraform has this concept of initializing, which essentially this is where the Terraform code that's in this ECS folder here comes into play, right? All this .tf files are Terraform related, right? The TF stands for Terraform, and it's a domain-specific language called HCL, HashiCorp language. And what it is an abstraction, right? So that it enables folks to build infrastructure using a common language across any provider. So you can use almost the same syntax structure across the board, right? And that kind of equals the playing field. So you don't have to learn a new language, unlike like a Pulumi, where you have to actually know a programming language to actually be effective in it. And then, so I don't want to get into deep in the weeds on the Terraform. You can actually traverse that. And I think the documentation for this is pretty well off. But I did want to show you like this is going to create a lot of infrastructure if you go through it, right? It's going to create ECS clusters, security groups in Amazon, roles. It also has auto scale groups, right? Which help with like scaling up and down your infrastructure when, like, let's say you have high demand periods. But again, the beauty of all this infrastructure as code business is it lets you codify all of these things and then also manage that infrastructure much, much more easily than having to go in to a AWS platform and or GUI console management and do it manually. So let's jump back over here. I think I got that code pressed. All right, I did want to cover one more thing with you on the config. The plan command, let me just go back down, sorry. I'm jumping all over. Here we go. The plan command. All this does is like a simulation, right? It doesn't really execute the actual Terraform. This is more like a, hey, validation system, right? Or validation function, just to make sure like your syntax is correct, or maybe you're missing something. It's kind of like a debugger or a linter for your Terraform. Once we run the plan, and then finally this command here is what actually, this command, all of this here is what actually runs your Terraform infrastructure, right? So your pipeline will kick off the Terraform CLI. It tells it where to find the code, right, in that folder. And then the apply flag is where the command will execute things. And then you just have these variable flags, right? All of these are set within the variable file, TF file here, or defined here. And this is just another way to make your Terraform a little bit more dynamic, right? That's why we're using environment variables, especially in the Docker image name. So we're going to deploy that image, and then we're going to have to supply the actual name, which is why I'm using, these Terraform variables. Finally, we're going to export the endpoint, right? So after all of these things is created, it's going to give us a endpoint, HTTP endpoint to call. And then finally, what this does here is saves that information to a file that we're going to use in follow-up CircleCI jobs. And then this sleep command, because, right, once we send off our Terraform to create all these things in Amazon, it takes time. And the system's not able to kind of understand when things are up and running. So I like to put a little sleep command to make sure the infrastructure is up and running before my pipeline, continues on. That's why that 90-second sleep rule is there. So I'm going to save that off and then prepare for the next module. So finally, right, like with that previous job that we created, we're going to go ahead and now deploy what we call a smoke test. So, right, how often have we deployed something to our production environments or an environment, and we think it's all hunky-dory, but it really doesn't work very well? That's what this smoke test job is doing. It's essentially just kind of giving us a warm, fuzzy test against that infrastructure that we created, so that we know that our Docker image, the changes in our Docker image actually function and were deployed to a functioning ECS cluster. So let's go ahead and copy that, right? And again, paste that through. So now we have our smoke test job, right? Which is really neat. And again, you can read up on what all these things are, since we are cutting it less than, almost 15 minutes. So I'm going to blow through this even faster so that we can see a working pipeline. All right, so the next step here, right, is we're going to build an ECS destroy job, right? So now we've created this cluster, we've run our deployment, we deployed our image to it, we've run deployment testing, smoke tests, right? And now we're going to basically delete all those things that we built, because we don't need it anymore, right? It costs money, it's a potential security hazard, right? So we don't want to give the bad guys any kind of way into anything that we own or run. So it's just best not to have it, right? So they can't hack what doesn't exist. And that's all this job does, right? It just runs a Terraform infrastructure as code command to destroy all the resources that were created in our previous pipeline. It's pretty simple. Again, you can read up more on that. I'm just going to go ahead and have you paste this here so that now we have a destroy AWS ECS job, right? Now, that should be all of our jobs in a list, right? So if I collapse all this up, there should be, I believe, 4 or 5 of these jobs, right? Build Docker image and then scan. Actually, there's 6 of them. So you should have 6 of these jobs, right, running. We'll just expand the last one because we're going to need to now cover, right? So now we defined all of the jobs. Now, that's great. If you were to run this or commit this and run it, it will just fail. The reason is CircleCI has to now understand how to run or orchestrate how to run these jobs that we've defined. This is where workflows come in with CircleCI. Right? So, let me just go ahead and cover that real quick. So building a CircleCI workflow, all it is an instruction set on how you want your pipeline to be executed. That's as simple as I can put it. And here's the workflows bit. So let's go ahead and copy that off. I'm going to quickly go through it here so that you understand what's happening. So now that we have our workflows job essentially, available, or our workflows defined, you can have these jobs run in different ways and you can have these jobs run multiple ways, and you can mix and match however you like, right? So what we call a workflow within a pipeline run, you can have multiple workflows that execute differently, right? Or execute jobs in different manners. Or maybe you don't want to execute all the jobs, right? Maybe you just want to run tests. You could do that by building multiple workflows. In this case, we're just doing one workflow. It's just like the jobs list, right? It's just a name. We're calling it build. And then within that workflow, we need to provide that workflow the jobs that it's going to execute, right? So that's why we have a jobs list here, right? Again, it's YAML. It's a data structure. So we have to create a jobs list. Like, all right, this workflow runs jobs or orchestrates jobs. We need to give it the jobs. And here's the syntax, right? We're going to run our tests job. We're going to run our scan apps job. We're going to build our Docker images. All three of these things are going to happen at the same time. Now, you might see that this looks a little differently, right? A little different. The reason why it looks different is I have what we call a requires statement. And the requires is basically creating a dependency so that the system will go ahead and block off how to execute things. So if you don't have a Docker image, you shouldn't have to build a cluster, right? So if your Docker build image either fails for some reason or whatever, it should not continue on. The pipeline will stop, and then the developer will be alerted and be able to fix that, right? So that's the whole point of kind of CI/CD, is to be alerted really, really quickly when you have problems with your code or your pipeline itself, right? And then here again, right, we're going to, after the deploy AWS ECS clusters built, it's going to go ahead and do a smoke test, right? Make sure that the system is working as intended, as designed, as expected. And again, we have to have a infrastructure up before we can run a smoke test, right? So that's why this requires statement here. And then the approval is just another, like, this is an actual job that doesn't exist in our list, but it's a special kind of job, right? You see the type, it's called approval. All that is we want to build in our workflow a manual stop point, meaning we want a stop point that enables, like, let's say you have a need for a manager to check people's work, or before maybe you have an SRE team that doesn't want automatic deployments, right? They want to kind of get eyes on things and then push a button to deploy. Same thing with our smoke test or with our destroy. I'm just slowing down the pipeline. Normally, I would just let this run and let it do it itself, but I like to, for demo purposes, have that. And then finally, when this button, which I'll show you, gets clicked, then this destroy action job happens, right? So let's jump back over. I'm really tight on time, so I want to kick this off. So finally, right, here's the final bit, right? If you haven't been following along or whatever, you can grab the code here. What we need to do next is just jump into triggering this pipeline. So now we built this awesome pipeline with all these jobs and all these cool workflows. Let's go ahead and basically commit this. So I'm just going to let me just copy it here and jump over to my IDE now. All we have to do is, remember, save off everything. You probably have one or two files, should be the main TF because you added your organization to it, or and this config.yaml file. So I'm going to go ahead. I only have my config.yaml file, so I'm going to go ahead and let's just do this. We'll do it with the command line. I'm going to paste this into my command line. Excuse me. Let's Control-C that. All right. Let me clear it up for folks. I like to use the command line. So there's my commands. And then all we have to do, right, to really get this moving or to trigger the pipeline is git push, which is the next command here. And once you have completed that, you should start seeing something that looks like this in the CircleCI pipeline. So we're doing great on time. So as you can see, right, it detected my changes. Here we go. These are the 3 parallel runs, right, that were orchestrated in our workflow. And what's going to happen is it should take roughly about 5 minutes-ish around there. But what you can see here is we're building a Docker image, right? So we've already run our tests. And I'm just going to talk through while this runs. We've run our tests, right? And you can see everything's cool. If you want to see the test results, you can see it in, I like to see the artifacts. So here's your test results HTML, right? It's just basically simple tests that we run. And these are native kind of Node.js tests, right? Oh, I just closed that out. Sorry. Let's go back to Sky app. I'm incognito. All right, let's try this. Apps. It doesn't want to remember. All right, so let's just go. I don't know why I did that, but that's okay. We'll just log in again. Simple. Yeah, all right, cool. So, yeah, so we built our Docker image, right? I was talking about tests, but basically I showed you the tests and that they're pinned, right, to the build. Let's go to the Docker image got built and pushed up to DockerHub, right? So this is really cool because if you go to hub.docker.com, you can see now that, great, of course, got to sign in. There we go. So you can see in my DockerHub repository, right? It pushed that new build up and it should be here. Here we go, a minute ago. So this is the image 155 that was built in this. And here you go. Here's the validation in this job. So if we jump back to our build, now this is where the deploy Terraform business is happening, right? So again, right, we're creating all of these AWS resources, AWS cloud resources, right, using infrastructure as code. Imagine if you had to do all this stuff in a GUI console. It would take, I guarantee it would take you at a minimum 45 minutes if you're lucky. But with Terraform, right, and the code, it's really quickly done because you can just execute it, right? So I'm going to pause right there while we wait for this. It's going to be a few more minutes. This usually takes about 5 minutes. So give some folks some time to catch up. Also, I'm going to check the Q&A if there's no questions. That's good. If you have any questions or comments, please feel free to send me some questions or comments or whatever. Otherwise, we'll just watch the paint dry here. Is everyone kind of following along or working well? I'm sure you're all feverishly working on getting this done. So, but what else did I want to cover? Right. So while we wait for that, I'm just setting up the accounts. Oh, cool. All right, awesome. Here, so let's take a look at this, right? So the Terraform apply ran. So that means our infrastructure was created and completed. Here we go. So remember when I talked about that load balancer host name? This right here is what it created. Let me jump real quick into the AWS console. Let me see if I can jump on it I can't do it here. So let me find another way. Sorry. I should have not used incognito. So let's go look at a non-incognito. Let me grab this real quick. I'm going to show you the infrastructure built in Amazon just so that you can see what that looks like if you're not familiar. Because there is, like I said, this is a very extensive workshop. It does a lot. So if you're not familiar with this, it can be quite intimidating. Well, not intimidating, but there's a lot going on. So be proud of yourself if you ever complete this. This is a lot to learn in 90 minutes. Okay, so let's see. Elastic Container Service. This is what we created. So our cluster is running. As you can see, we have one service. There's no task yet, which means the image has not been deployed yet. That's probably due to the fact that the infrastructure is still being built, right? If you look here, EC2 ECS instances, yeah, we don't even have instances up and running yet. It just takes a few moments of time. So let me jump across here into the workshop again. I think it was here. Let me get rid of this. Yeah, just because it's finished here, and again, right, that's why I added that 90 minutes hold. Just because it's finished here doesn't mean this is ready. But if we were to go to that URL, which I'm going to paste here, it will probably not. It will not. It should not show up yet because things see. It created the application load balancer, but the underlying images and clusters still not quite connected yet within AWS. Even though our 90 minutes has completed. So let's go back to our build pipeline, our smoke tests, right? So remember I said I want an automated way to test. This will probably fail or time out because, again, the system itself is not ready. So if we jump back over to our AWS console, let's do a refresh here. We should see, yeah. So it's starting to build out, right, those EC2 instances that we need. And shortly, it'll start populating it with proper images. See, we have one running task, one pending task. So our website should be up and running. Let's go ahead and try it again. Hopefully our smoke tests have passed. Nope, still not ready yet. But we'll go ahead and find where we were. Right, so the bad gateway, no bueno. Our smoke test failed. This was expected, right? Because of the amount of time that the system needed to kind of rebuild itself. So let's go ahead and if the smoke test failed, right, what you need to do is we'll give it a few minutes, a few minutes. But the beauty of this is when your smoke tests fail like that, you could actually rerun this job. Let me just click here on the build, click on the job again, and that'll refresh the UI. And then you can rerun this workflow from a failed point, right? I strongly recommend that you click this from the failed location, right? So you don't have to go through all the machinations of all the other build processes, right? So as you can see, it's just going to start, building from the point of failure instead of rerunning that whole thing. And it'll be a lot faster. But here we go. Our smoke test passed this time, right? So again, if you run the rerun workflow from failed, because the system is now available in AWS, our smoke test passed. So if we jump back over to the build, workflow build view, you can see we have all our things passed. AWS is working. If we jump over to the AWS cluster, we do a refresh, you'll see these numbers have changed, right? Now we have 2 running tasks, 1 pending task. So the system is coming online. If you dig deep into it, we got 3 minutes left. So I just want to show you the instances are there, right? These are like all the ARM instances that are running, and it's running our application. So let's go ahead and refresh this. We should see, yes, there's the application. If you go to that endpoint that is specifically to you, you should be able to see this application running in Amazon's ECS. Now, the great part is, like I said earlier, let me, sorry about that. I got multiple windows over there. There we go. The great part is we can destroy all this, right? So we don't need this anymore. We know that our application changes are working. We deployed them on the target environment, which is Elastic Container Service. We smoke tested them. That gives our app team a great confidence in that build. And now we don't need any of this stuff, right? So this is where that manual approval job step comes in. We just click this approve button. And what that does is it kicks off the destroy AWS ECS job, right? So now we can just basically terminate all the things that we created within Amazon so that we don't have to worry about, again, costs getting out of control or maybe potential security exposure, right? So basically that's it. I have 1 minute left. I just wanted to thank everybody for coming. Sorry I blew through this, but yeah, I definitely wanted to thank everyone for coming, and reach out to me if you have any questions on this. I'm sure the team at DevOps.com is going to be able to forward me some questions as well. But you have ways to get a hold of me. Please do so. I really appreciate your time, and hopefully, we'll be in communication. Thank you so much.
Hey, Angel, before we let you go, we do have one question that we might as well knock out while we're here. So this participant asks, can we put retry in place of rerunning manually?
Oh, yeah. So right now, I think the reason why there is a way to hack through it. I would recommend you don't do that. The reason why these failures exist is for your pipeline, to flag things, right? So if you kind of say, hey, ignore that, then it's going to, what are you ignoring? Is it a bug? Is it that, some weird thing? Now, for that particular one, I'll just give you some advice. You see that sleep 90? All I really do is bump it up maybe 10 seconds more, whatever that looks like. I hate doing this, but I do it for demos because, you want these things to be really fast. You don't want these things, going on for 20 minutes, half hour, an hour. You want these things to be lightning fast. Unfortunately, it's out of my control because Amazon does the way, builds this infrastructure the way it does it, and it just takes the time that it takes. But once you have this up and running, you don't have to destroy it, right? You can do subsequent calls against it, and that'll make it run super fast. So the answer is, for this particular problem, which is a sleep, a race condition, essentially, things are not ready yet, then bump that sleep up to, I don't know. I try to do 10-second increments, right? Just to maybe 20, but I try to keep these very lean. So I hope that answers your question, man. If not, ping me and we'll talk some more.
Awesome. Thank you, Angel. And if anyone does want to reach out to Angel, his Twitter and LinkedIn handles are @punkdata. So any questions, there we go. So
and
Angel,
feedback, please. I appreciate it. Thanks.
No, I really appreciate you taking time to walk us through this workshop. We got a lot of positive feedback, and I think a lot of people are going to use this workshop. So thanks so much for putting all the work and time into it.
Oh, no worries. Thank you.
So to everyone who was following along with us today, maybe you weren't able to follow along with the entire program. Maybe you were setting up some accounts. Just rest assured this program was recorded. It should be emailed to you shortly, but otherwise you can find it living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. At the top of the hour, I promised 4 $25 Amazon gift cards. So our first winner is Kenneth F. Our second winner is Alexi D. Our third winner, DeWitt G. And our fourth and final winner is Mayor T. So to the four of you, congratulations. Keep an eye on your inbox to claim that gift card. But if you don't happen to see that email, keep an eye on your spam folder. So
congratulations,
we'd like to thank
everybody. That's awesome. Where's my gift card, Cody? No, I'm just kidding.
Oh, it's on the way.
Yeah, right. Thanks.
Awesome. So thank you to AWS and CircleCI for sponsoring this webinar, and to our audience, we really appreciate you hanging out with us. As soon as this webinar closes, a survey will pop up on your screen. So we really want you to fill out the survey. Let us know what we can do better. Let us know any feedback you have for today's workshop, and we can also relay that message back to CircleCI. So we hope to see you all at an upcoming Techstrong learning program. Everyone, have a great rest of your day. And Angel, thanks again.
Thanks.